Okay, hope this helps with your right triangle trig unit here. If you look at the first one here, we're solving for sides or angles in this unit. If you have two sides and you need the third in a right triangle, please feel free to use Pythagorean theorem because that's how you'd want to do this problem. A and B are your legs, and the side I'm solving for here is my C, or my hypotenuse. 2 squared plus 3 squared equals C squared. 2 squared plus 3 squared is 4 and 9, which totals 13. Last step in Pythagorean theorem is to take the square root. Square root of 13 is ugly, so feel free, or irrational, to leave it as the square root of 13. Moving to the next one, the next two right here. In these two problems, you're solving for an angle. In this first one, let's say we want to solve for A. If you want to solve for an angle, you're going to be using inverse. And you need to know what you have. For example, with A, what's labeled here is my adjacent leg and my hypotenuse of the right triangle. So I have an A and an H. Hopefully you remember SOHCAHTOA from geometry. That is our cosine. So I'd put in my calculator inverse cosine 7/8. Please double check. Make sure by hitting mode that your calculator is in degree mode. Usually it's the third or the fourth one down. And then simply type that in, inverse cosine 7/8. The angle is 28.96 degrees. Okay, let's go to the next one. Let's say in this one you want to find angle B, this angle at the top. Now this leg down here at the bottom is no longer adjacent because it's opposite of this one, so it's an O, and hypotenuse is always your hypotenuse. That's your long side across from your right angle. So if you have an O and an H, if I look up here, that's sine. So I'd write inverse sine, and this was my opposite. I don't want that to look like a 60. Opposite was 6, and hypotenuse was 11. Type that in. Second sine, so I get that -1, 6/11. Answer's 33.06 degrees. Okay, the next thing they could give you is 3 sides of a right triangle and ask you, hey, does that really make a right triangle? Anytime you have 3 sides and you really want to prove if it's a right triangle, you just simply plug it into Pythagorean theorem and see if it works. Pythagorean theorem is a squared plus b squared should equal c squared. And I put a question mark because I'm not quite sure, but let's see. 6 squared is 36, 8 squared is 64. If I add those together, I get 100. 10 squared is also 100. Check. It works, so it is definitely a right triangle. I can definitely keep that right angle symbol in there. Okay, and my last two are using right triangle trig, again, SOHCAHTOA, to solve for a side this time. It's a little different. Here's my angle. This side that I know is opposite. This one is my hypotenuse. So I have, let's do O and H, that's sine. So I'll do sine of 40 equals 11 over, we can call that b, little b, because it's across from big B. And to solve that, I don't like fractions, so I will multiply both sides by b, cancel those out. So now I have b sine of 40 equals 11. And then I will divide by sin 40, or sine 40 on both sides to find out what b is. So I'll use my calculator. I'll put in 11 divided by sine of 40, and I get 17.1 for my hypotenuse. So 17.1 is that missing side. Now I want to go, I'm going to switch these actually. I'm going to say this side is an 11, and this side we'll call little c because it's across from big C, or maybe there's just an X on it when you do your work. So here's the angle, or the acute small angle that I'm given. This side is opposite. This side right here is adjacent. It's right next to it. So if I have an O and an A side, I'm going to use T for tangent. I will write tangent of 39. Notice no inverse because I'm not solving for an angle, equals. The opposite side, I don't know what it is. It's labeled with a C. My adjacent side is 11. Again, I don't like fractions, so I immediately multiply by what's in the denominator, which is an 11. Type this straight in on the calculator. 11 times tan 39. I get 8.91 equals C. I actually prefer when my variable is on the top. Hope that helps.